Hi, for the first video for this chapter on Introduction to Proofs, we're going to talk about algebraic proofs. Now, the reason that I like to do these first is because basically you're taking what you learned in algebra, which is a lot of solving equations, and you're just using that process to learn how to write proofs. So, if we flip through the first couple of pages, before we start doing any real proofs, there are a couple of properties that you need to know. Now, in the very beginning of your packet, there are 2 pages that you should just fill out randomly when I give you either definitions or theorems or properties. So the first page is all about vocabulary. That needs to be filled in when you turn in your packet. So every single word on that sheet has to have a definition. The second page is a place to put all of your theorems and properties. Theorems and properties are basically things that you can use to help you do a proof. What I want you to do with every single one of those is put them in if-then form if you can. It'll make it a lot easier for you. So our first property is the reflexive property. And basically the reflexive property says that anything, spell it right, anything is equal to itself. So that kind of seems like common sense, but we will actually use that a lot, especially when we start to do harder proofs. So if we take a look at the picture down here, I could say something like, what do they share? Angle A is equal to angle A. So I can go into my little menu book here, find my symbol for angles, and I can say that angle A is equal to angle A. Now, when would you ever use that? Well, if you're trying to take the 2 triangles that are kind of overlapping there in that picture, and you're trying to prove that they are the same, one thing that you can use is the fact that they share an angle, or that angle is the same in both triangles. So it is something that is helpful, and again, we'll use it a lot more later on. So for right now, make sure that you have it written down, if nowhere else, on the theorems and properties page in your notes. Okay, the next one is the symmetric property, and basically the symmetric property says that you can take things and put them in a different order. So you can switch the order of an equality. So down here, if it says that AB is equal to 6.06, we can also say that 6.06 is equal to AB. So again, just taking the 2 things and switching the order. Alright, transitive property is probably the one that we will use the most. That one says, and this one I'm actually going to put in if-then form. The other 2 are kind of just straightforward statements, but this one you can actually put in if-then form. If A is equal to B and B is equal to C, then A is going to be equal to C. So A, B, and C can be whatever. They can be sides, they can be numbers, they can be values, they can be angles, it doesn't matter. But if you have one thing, A, equal to something else, which is B, and then B is equal to a third thing, which is C, then those first things, the first thing and the last thing, have to be equal. So basically it's just saying that all of it is equal, and it's just kind of a fancy way to say if 2 things are equal, and this thing's equal to another thing, then basically everything is equal. So in the picture we have segments. We have AB equal to CD, and CD is equal to EF. Well, if AB is equal to CD, and CD is equal to EF, then we can say that AB is equal to EF. Alright, so again, those are probably the easiest properties that we'll take a look at this year, so I just wanted to make sure that we started with them. Alright, we're actually going to start looking at proofs. Usually when you do a proof, you will do what we call a 2-column proof, and if you look on the screen here, I have these 2 columns. One column we have the statements, and the second column we have the reasons. Statements are things that you know are true based on your given information, and reasons is exactly that. It's a reason why you know each statement is true. The other thing that you will be given when you do a proof is some given information. So I, or whoever is writing the proof, will have to tell you some stuff to kind of get you started, and then we will ask you to prove something. So what we have here is that CD equals 2 inches and XY equals 2 inches, and we want to prove that CD equals XY. Now, you on the Regents exam will not see a proof like this. Okay, this is kind of a really simple one to get you started. When you start a proof, no matter what the proof is, you usually put your givens in there first. It's kind of the easiest way to get started on a proof. So what I'm going to do is go over here and copy. So if you hit the shift button and the back arrow or the forward arrow, whichever direction you're going in, it will highlight it, and then hit Control C to copy, go into the statement column, and Control V will paste it. Now, how do I know that that statement is true? Well, it was given to me. So I know that CD is equal to 2 inches. I'm putting it in my proof, and then I have to give a reason. The other given is that XY equals 2 inches. So again, I'm going to copy that, Control C, and then I'm going to go into my statement and paste it, Control V. And I have to give a reason again. Well, that also was given to me. Now, if CD is equal to 2 inches and XY is equal to 2 inches, then CD has to be equal to XY. But one thing that you want to be careful of when you write a proof is that if you're going to use that transitive property that says if one thing's equal to another and that other thing's equal to something else, the two equal things should be across from each other, kind of like linked when you read them. So right here, if I could just switch XY is equal to 2 inches to be 2 inches equals XY, then that will help me out. So I'm going to say 2 inches equals XY, and whenever I switch something like that, just take something and flip it around, that's the symmetric property. So again, I write something down and then I give a reason. Now, if I take this first statement, CD equals 2 inches, and I take this third statement, 2 inches equals XY, I have the transitive property. CD equals 2 inches equals XY, so then CD has to equal XY, and that's the transitive property. And that's it. So basically when you do a proof, what you want to do is start off with the stuff that you're given and end up with the thing that they want you to prove. And just show a couple of steps in between. For some proofs it'll only be 1 or 2 steps. As we get into harder proofs, you may have a proof that's 10 to 12 steps. It just depends on the problem. Okay, so what we really want to take a look at today is algebraic proofs. So now that you've done your first proof, let's do a few things that we should know how to do already. Okay, what we have here is an equation, 3x plus 2 equals 14. Now, I've given you the answer, x is equal to 4. When you do a proof, it's not really about finding the answer, it's about proving that you can start with something and finish with something else. So we want to show how we start with this equation and end up with x equals 4. So let's talk about work. Normally what we do when we solve something like this is we would subtract 2 from both sides and get 3x equals 12. Now, what did we do to go from the first step to the second step? We subtracted. So we used the subtraction property. We subtracted the same amount from both sides. At this point what we would do is divide both sides by 3 and we would end up with x is equal to 4. So to go from this step to x equals 4, we use the division property. So again, what we want to do is write that up as a proof. We're going to start out with the thing that we're given. So again, I'm going to grab my given statement, copy it over here. The reason that I know that that is true is that it was given. Now, everything below this was not given to me. This is the work that I did to try to figure out why x is equal to 4. But this is the second statement that's going to go in my proof. Now, the reason that I know that 3x is equal to 12 is because of subtraction. Okay, I subtracted 2 from both sides and got 3x equals 12. And then I ended up with x is equal to 4. And the reason that I know x is equal to 4 is because I divided both sides, so I used the division property. Okay, so again, really all we're doing is taking an equation, solving it, and then giving reasons for each step in the reasons column. Alright, next one, we have 2 equations. 5x plus 2a equals 16 and a equals x plus 1. We want to prove x equals 2. Well, the first thing that we're going to do here is take this, x plus 1, and plug it into the equation above it wherever we see a. So first thing I'm going to do, like always, is take my 2 givens and put them in my proof. So the reason the first statement is true is because it was a given, and the second one was also a given. Alright, so now what I'm going to do is take this first equation and wherever I see a, I'm going to replace it with x plus 1. Now, what did I do there? I took something and plugged it in for something that it was equal to. That's called substitution. And now what I'm going to do is go through and solve this equation. So the next thing we would do is probably take the 2 and distribute it. So we would get 5x plus 2x plus 2 equals 16. So what we did there is distribute, or distributive property. Now, at this point normally we would probably combine like terms. So we have 5x and 2x, which is a 7x, plus 2 equals 16. So what we did there is combine like terms. Now, next thing we would do is subtract 2 from both sides. So we would get 7x equals 14. What we did there is subtraction, so that's our reason. And then the last thing would be to divide both sides by 7, and we would end up with x is equal to 2. We divided both sides, so that's our reason, division. Alright, next one, we have a equals x and x equals 7. And we want to prove that a equals 7. Well, this is straightforward transitive property. Basically what you need to do is just recognize that it's saying a equals x and x equals 7. You have the same value on that diagonal right there. Those two things are across from each other. When you read it, they go in order. A equals x equals 7. So the x's are kind of the things in the middle that are going to get crossed out, and a will equal x. So this one's really simple. We take our two givens and put them in the proof. The reason we know that those two things are true is that they were given to us. And then the last thing that we put in the proof is what they want us to prove, a equals 7. And we know that that is true using the transitive property. So even in an algebraic proof, you can use those properties: symmetric, reflexive, and transitive. Alright, so that's it for algebraic proofs. Tomorrow in class, or Monday in class, what you'll be doing is going through solving equations, making sure that first of all you can solve equations, kind of get that skill back from algebra, and then for the should do part you will be putting your equations into proof form, so into the 2-column chart with statements and reasons. Alright, so that's it for the video.